Start. So welcome to today's undergraduate teaching module on produce safety. This is one out of two modules that are targeted towards undergraduates that want to learn more about produce safety. What we're going to learn today is how foodborne illness outbreaks are investigated, with a specific focus on the challenges experienced by both industry and government agencies during outbreak investigations. And we're going to use produce as an example for this. We're going to understand at the end of the day how the complexities of produce production, processing, and distribution complicate outbreak investigations. And we're going to learn a little bit about two key foodborne pathogens of relevance to produce, E. coli and Cyclospora, so a bacterial pathogens and a parasite. And we're going to learn about these by case studies. And so what we're going to do here is we're going to take past outbreaks and talk about them. We're not going to try to recreate exactly what happened in this outbreak, but we're going to talk about the things that could have happened, that one should have considered, some dead ends that one might have found, to make this more realistic. And to do this, I have Samantha Bolton and Alex Belias join me because we're going to make this a little bit of a conversation and discussion. So here's our first outbreak. It's an old outbreak which occurred in 2006. And here's sort of the basics of this outbreak. From a CDC, what they call the final summary. So this outbreak included almost 200 people, so 199 people that were infected with the outbreak strain of E. coli. And there's the basic information. 102 of the ill people were hospitalized, so that's about 50%. 31 developed kidney failure, a hallmark of 0157 infections. And so on and so on. So this is your typical sort of outbreak summary. And it also gives you a range of when the illnesses occurred, which is important. It says 80% of people became ill between August 19th and September 5. So that sort of defines that key area. And then it talks about number of deaths that occurred, et cetera, et cetera. So the first question is like, how is an outbreak like this detected? Usually, and I have a prop for this. So if you take this outbreak, Alex, what do you think is the most likely way how this outbreak was detected?
So health departments screen certain foodborne illnesses that come into hospitals or doctors' offices, and they gather isolates, or they collect isolates from those patients. And they perform subtyping on the isolates that they gather to determine if there's any sort of match between past isolates or other isolates that they've collected from people recently. So if there are any sort of matches, or if there is just an increase in cases above a baseline, there's evidence that we might have an outbreak. And from there, they start to look at what product might be causing it.
Okay. When we get to that part of the product first. So yeah, so essentially we have a very effective surveillance system where when a person goes to the doctor with diarrheal illness or more severe illness, as in this case, and they're diagnosed as a likely E. coli case, stool sample will be taken by a doctor. Doctor sends it to the lab. The lab will test for E. coli or these enterohemorrhagic E. coli. If they find one, they typically in most states have to send it to the state health department. So that's called mandatory isolate submission. And then the state health department will take that isolate and perform some sort of DNA fingerprinting. Today, this is whole genome sequencing. Back in this outbreak, it was PFGE, which is sort of a banding pattern barcode that's a DNA fingerprint. And what you would see is something like you see here, where you have lane 4 and lane 7. You can see these would be 2 E. coli from 2 humans, and you can see these two are the same. In our outbreak, that would be like 199 E. coli that all had the same or maybe close related banding patterns, where someone says, holy cow, we got a lot of people here infected with the same fingerprint of E. coli, they must have something in common. And usually that sort of holy cow moment happens anywhere from 3 to 4 cases to maybe 20, 30, 40 cases. It The trigger is a little bit different. It differs between PFG and whole genome sequencing and on a lot of factors, and that's not that important. But so typically today, for these outbreaks linked to proteins, it's triggered by a subtype, by multiple isolates, the same subtypes isolate from different humans. So what we have in this case is, and this is probably how this started, we have like 30, 40 people at some point in August, same fingerprint of E. coli. So that tells us we have a cluster. Cluster is a number of cases that are close related. Typically, it doesn't mean it's an outbreak yet. An outbreak means it's linked to some sort of food. So once we have that cluster, and this shows how it's detected, you know, we have the sort of central database. It's called the PulseNet database. Each state feeds their data to it, and that's how we detect clusters, and that's what we are going. So once we have a cluster, what's the next step, Samantha? What happens after we have a cluster? So we have this holy cow, we got 40 people with the same subtype moment. What's going to happen now?
You're going to collect data about what those people who are within the cluster, what they were eating, and see if you can find any type of correlation or association at all of things that they were eating. So this is through like hypothesis generating questionnaires, right?
Right. So it's through questionnaires. So what typically would happen is, okay, we got 40 people. Let's say, for argument's sake, they're in 5 different states. So these 5 states are going to start using the epidemiologists to call up these patients and say, what did you eat within X days before you start getting sick? That X days, what is that going to be for an E. coli 0157 case? What do you think?
It would be 3 to 7.
3 to 7, because that's the incubation. It can be shorter, so it's probably something like 2 to 7. 1 to 7, so I actually don't know exactly, but it's a specified time period, right?
Right.
And so we start asking the people what they consume. So let's say we do this. So what do we expect there? Do we expect like, oh my God, they all say they ate French fries, and therefore it must be the French fries? Is that what we're sort of looking for? What are we looking for when we do this?
It's probably not as easy as they all ate French fries at X restaurant. But we're looking for some type of similar food that was consumed within the time period.
So all 40 need to have the same food? Is it enough if
it's enough?
How many? If it's 90%, it's enough? 95%?
I would say a bit over half.
Okay, so as long as 60% say it's spinach, you're gonna say it's the spinach. Okay. Does it matter what food it is? If 60% say it's spinach, is that as meaningful as if 60% say it's smoked pork tongue? Which will be stronger evidence of a 60% say it's smoked? So let's say in this outbreak, we interviewed them and 60% of people say we ate smoked pork tongue and 60% of people said we ate lettuce.
I think that smoked pork tongue would be more associated because lettuce spoils more quickly. So the lettuce that you ate might not be the same as the lettuce that the 40 other people who are part of that cluster ate, for sure.
Alex, what do you think? Is it the lettuce or is it the smoked pork tongue, and why?
Well, this one can kind of go both ways. So I would say if you've had like 80% of the people say they ate smoked pork tongue, I would definitely go down that route because that's not something you forget about as easily as with, say, lettuce. So lettuce could be on a sandwich or a burger and people don't even realize that they're eating it. So they're more likely to forget it, which is kind of why you would get to that 60% number.
Yeah, good point. So just a cutoff, right? A percent cutoff doesn't quite cut it, pardon the pun, right? That doesn't seem to work that well. So often we want more information than that. But conceptually, step one, we do a food questionnaire, and then we have to analyze and look at those data. So let's see what this looked like here. So in this case, sort of the final report, and that is copied from a paper among 176 confirmed primary case patients with completed questionnaires. So it's only a subset of these 200 that actually complete the questionnaire. 91% reported eating spinach during 10 days before illness onset. 12 patients denied consumption, didn't eat spinach, hate spinach, and 3 didn't remember. And then when we talk about the patients that consumed spinach, that sort of range from bagged fresh spinach to, raw, ate blah, 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 et cetera. So strong evidence that it's the spinach. Would you, if this is your company, would you roll over saying, yeah, that's got to be spinach? Or if you're the spinach board of the US, would you roll over and say it's the spinach with this information, or would you ask some pointed questions here?
I would ask pointed questions.
Like what pointed questions?
Like if there are so many people who are saying that they ate raw spinach, like how do we know, like if it's a processing facility, I would ask how do we know that spinach came from a bag versus a clamshell container?
Well, because 83% said bagged fresh spinach. We asked them, right?
And they specified that it was a bag.
Well, that's what I'm told here. So, maybe not, I mean, we're digging down, is it the bagged spinach or that, but is it spinach in general? Will this give you enough information to convince you to say it's spinach, or what else would you want to know?
I would ask how many people that ate spinach didn't get sick. So do we have any data on that?
Well, and how many people that
ate spinach and didn't
like
get
among
sick?
all the 330 million people in the US, or?
Well, that's not possible. So the CDC has a study on consumption patterns that they use to compare.
So you'd say, okay, there must be some study out there, and there is saying, on average, over 10 days, what percent of population in the US eats spinach? And if it's on average 40%, and here it's 90, then Alex would do some stats because she's good at that. And so, 90% is significantly more than 40 in this case. And it wouldn't be on a percent value, so it would be absolute. So therefore, it's a significant association, yeah. And so that's what often is done. You compare to past data, consumption history or historical consumption patterns, which is, fraught with problems, which we can discuss. But the other thing, the first thing is like, okay, what else did you ask? Did you ask people just about spinach? Did 100% of people eat hamburgers? I mean, give me something else. This is not, did you ask broader question or not? So just reporting the question on spinach is a little bit limiting because it could be other things too. And so I would want to see what the other questions were asked. In this case, I couldn't figure it out actually from the outbreak investigation. I'm not saying it didn't, because we're going to take some liberties here as we discuss this outbreak. It doesn't have to be exactly what happened because some stuff we don't know. But what you typically would get is something like this, and this gets arise. When you have an outbreak, you have cases. So these are people that are sick, and we're going to interview those. So in this case, in this outbreak, we had about 18 cases, different outbreak. We say, okay, what proportion of people ate onions, lettuce, potato salad, and so on and so on. And then we're going to ask our controls, so people that did not get sick. And so we come up with a control group. So this would be a case control study. And we're going to ask them the same questions. So patient 1, is a 20-year-old college student that got sick. We're going to find another 20-year-old college student that didn't get sick and ask them the same question. So that would be our case control study. So in this case, which is a different outbreak, the cases were much more likely to eat frankfurters, beef, and ham as compared to the controls. So for example, for frankfurters, cases 16 out of 18, 6 out of 19 for the controls. But it also shows that, how this can be sort of challenging, because chicken, all patients said they ate chicken, but the controls very frequently ate chickens too. So it's not the absolute percentage value, it's really over expected, right? So often in these outbreak investigations, you want to dig back and say, what other questions were asked? What other foods are there? What's the number 2 suspect? What's the number 3 suspect? To just get an idea of the overall feeling, of the overall data that support a certain food item. The other thing, what often people fall into the trap is that, well, 12 patients didn't eat spinach, so it can't be the spinach because I'm expecting 100%. There are a number of reasons why you wouldn't expect it. Number 1, people forget what they ate. Number 2, people ate spinach, but they didn't realize it. It was a mixed salad mix. They didn't realize spinach was in there. Someone snuck spinach in their food. And with some diseases, there are secondary cases. Your friend got sick with E. coli, made you a nice meal, didn't wash his or her hands, and infected you. So actually didn't get it through spinach, but he got it from someone that got it from the spinach. So there's a number of reasons why this would happen. So you don't expect 100%. Sometimes people in the food industry that are sort of newer, this is like, well, it can't be spinach. It can't, because like some people didn't say they didn't eat spinach, so it can't be us. No, not so fast. Okay, so that's how we get to the second step. So, okay, so we have an outbreak, we have a cluster, we find a commonality, now we know it's spinach. But that doesn't get us far, right, in terms of where it comes from. So the next step is then figuring out, okay, where did this come from? That typically means going back to people and say, okay, what spinach did you eat? What brand do you remember? And in this case, that's exactly what happened. A number of people identified brand A. And if your product is our called brand A is always the suspect. It is always the culprit at the end of the day. Identify brand A, and so therefore we have a high suspect. Some of them also had brand B, but when you have a code on the bag, sometimes you can find out that brand A and B might have been produced in the same facility. It's very common, not just in produce, that you have, Wegmans lettuce or company X lettuce and company Y lettuce, Wegmans and Walmart lettuce, or whatever it may be called, come from the actual same facility. So in this case, people identified a certain brand, and open bags of spinach were obtained from people in 14 states. And these were then available to be tested. Once you have a bag, you have a lot number that indicates a production shift, a production line. And so we can trace back. So what shift it was produced, what line it was produced, et cetera. So we can start to trace it back pretty specifically to a given facility in this case, okay? And so that's what happened here. So it was with this information, we were able to trace it back to a specific facility. This is unusual that a lot of patients have open bags of spinach or a product left. In many cases, you don't have that product. Sign of caution, open bag, testing it and finding E. coli, is that good evidence? So let's say we have one open bag. We have this big outbreak. One person has an open bag of lettuce. It's Dole's lettuce. We test it, we find E. coli, we fingerprint it, matches the outbreak. Does that mean Dole is responsible for this outbreak in this case?
No, if it's just one open bag, it could have been cross-contamination in like the person's fridge from another product in there.
Right. A little bit of this is a chicken and egg question. Well, the lettuce could have made the person sick, or the person was sick, didn't proper hygiene and contaminated the lettuce, or the lettuce was cross-contaminated from meat. So evidence on outbreak investigation based solely on a single open bag of a certain product is always highly suspect. Whenever something like that comes to me in the industry, I was like, okay, so you found it in my product. Was it opened? Was it unopened? Key question to ask can make a big difference. This case, slightly different story, 45 bags of opened product. If a number of them test positive, then that's a different story. So here's what you see on a bag. So once you have these bags, which very often does not happen, you can trace it back to a certain, production facility, hopefully, and find out what might be going on. In this case, then you also tend to get data on, where does the outbreak occur? And so in this case, the outbreak had sort of an interesting pattern in terms of states where it occurred. So Alex, when you look at this pattern, I say, here's an outbreak, here's where the cases occurred. What strikes you when you see a pattern like this?
So it's not It's two distinct areas. So if you have one distinct area, you would start to look at maybe there's a smaller production facility that only ships to those areas, or if it's the entire country, it's a larger facility that ships everywhere. With the two areas, maybe it's even easier to identify based on the company's distribution patterns. But yeah, it's interesting that some states don't have it.
So when you see this, and this is also often a pattern, you see, some states have it, some don't. So this is like, well, maybe it's two facilities, right? We could look at one in Utah because that has a lot of cases, and one in Ohio because that has a lot of cases. So someone could look at it that way. So that could be one thing, not the conclusion I would draw, but some could. And then maybe it was one produce field, and it was produce produced in some part, Mexico, Arizona, California, you name it, and it was shipped to two processing facilities. That could be one thing that one might think when they see it. Another thing might be, well, maybe it's one facility that has two distinct shipping pathways. They don't ship all over the US, but it just shipped to two different states. But then the word of caution is, well, not every white spot is truly white, right? This one is North Dakota. 0 cases in North Dakota and 2 cases or 1 to 4 cases in Minnesota. Is that really a difference? Does that really mean there were no cases in North Dakota?
No, I doubt it. North Dakota just has a lower population, which is probably accounting for the lack of cases or lack of identified cases.
So lettuce might sort of ship to North Dakota and South Dakota. We just happen to not pick up the cases there because there's so much fewer people. So it doesn't. So again, if someone says, well, this can't be us because we also shipping to North and South Dakota, so it can't be our product. And this is if you work in the food industry, one of the two of you. That's like someone's going to ask you to look at it, and your CEO, sorry to this CEOs might say, well, it can't be us because I know we ship into North and South Dakota. There are no cases. Can't be our product. Then you gotta say, not so fast, right? I mean, because it probably isn't detected there because we see very few cases. So those are some of the sort of misinterpretations that occur with maps like this. All right. So we have this. Then another piece of evidence often are these sort of epidemic curves, which show you when most of the cases happen, when they went back down. So this is the type of information that all has to be taken together to sort of identify possible source of an outbreak. And you might have some more detailed charts over time, and there you see these secondary cases, which is these cases that I described, or can be these cases I described. Your brother, your friend, your significant other got the disease. They were shedding it. They were making you some nice meal and infected you. Very often it's in daycare facilities where one baby or one kid gets diarrhea and then infects a bunch of other kids. So we see these clusters of secondary cases somewhere, which is one of the multiple explanations why you don't expect everyone to say they ate spinach. So this is sort of how we identify an outbreak, identify the food vehicle, trace it back to a facility. And you can see, learn that this is sort of not a super accurate science necessarily. There's a lot of sort of assumptions in there that people remember things correctly, et cetera. And so once we have this, then, we can trace it back further. And the question becomes, where did it come from in this, for produce, which farm, which growing area did it come from? So in this case, this was traced back presumably to a San Benito County farm. And we can see here that the outbreak strain was found in 13 bags of Dole brand baby spinach. And that was traced back ultimately to a field, to 4 fields and to counties. And I'm not saying that is what the 4 fields are the only source, but that's what it was traced back. And then was found in the same strain was found in environmental samples. So this might be soil samples, water samples, and were limited to one specific farm. And then that farm, they found it on river water, cattle feces, and wild pig feces. And they had a grass-fed cattle operation less than a mile from the spinach field, and evidence of wild pigs in and around the cattle, etc. So what does that suggest to you, this picture here? Well, what happened here? How did this product get contaminated? What do you think, Alex? Well, Samantha, go ahead.
I would say that it was likely directly contaminated by water, probably. But the water was contaminated through either wild pig feces or cattle feces.
Okay. And so why from the feces to the water to the spinach? Why not from the water to the cattle to the spinach?
Because the particular pathogen, E. coli 0157H7, is more associated with cattle.
Yeah, and that's one of these myths we're gonna bust here. Of course 0157, as some of you might know, it was first identified as a strain that was caused disease in undercooked ground beef. So there's always, so from that early outbreak and outbreaks linked to ground beef, it's basically when you have an 0157H7 outbreak, everyone's looking for a cow because it has to be the cow. And it might be the case. I'm not saying it isn't, but I think we have often these myths, and we'll see some other ones. You know, if it's Cyclospora, our next case study, it has to be Mexico. If it is 0157, it has to be a cow or cattle. It has to be a CAFO. Now, that might be true, but it's not always true. And so we need to be very careful about this, particularly with directionality. So it could have come from the pigs. It could have come from the cattle. It could have come from water. There's no directionality in these data. It just shows us that this subtype has been frequent in this area or is found in this area. And you know, it probably traces back to one of these sources, but the details are really difficult to figure out. I mean, it's easy to have hypotheses. It's very difficult to prove those. So this is what typically happens in these outbreaks. So we trace it back, we then draw some conclusions, and here's a long set of additional possible conclusions, talking about groundwater levels that could have allowed sort of some of this contamination pulled into the ranch's groundwater, and that then, you know, probably implying that the groundwater was used for irrigation and so on. So at the end, you know, there's a lot of other things, because then we also have the field was fertilizer used in the field was heat-treated chicken manure pellets. And there's definitely some evidence out there that often these chicken manure pellets can be carriers for pathogens. So it gets extremely messy often when we go back to the field in terms of finding the real primary source. And that's what I really wanted to sort of illustrate with this set of slides. And adding to the complexities, then the complexity of the supply chain as we trace back. And I think that's what also particularly in the produce industry, but everywhere is, you have a supplier, a point of service, it could be a retail establishment, something like that. You have a distribution center, you have a processor, you have grower harvesters that go to multiple ranches, go to multiple fields, and sometimes, and so on. And this is a pretty straightforward relationship. It often gets much more complicated than that. So tracing an outbreak from a person to a point of service all the way back to a field can be extremely, extremely challenging with all these complications. I'm gonna skip this one here. And then, this is sort of a picture of the idea of what happened in this outbreak potentially, where you had, water, streams, cows, wild pigs. I think these must be wild pigs or so. The idea of it, maybe it's wild pig feces, I don't know. But it's very, very difficult to trace this back definitively. And I think often you may end up with like, well, it probably was the spinach that played a role, but were all cases spinach? Could you have had one or two cases due to undercooked ground beef that can be traced back to the cattle on this cattle ranch? Could we have another outbreak 2 years later that now is not spinach, but is from the cattle and could have the same subtype? Things like that are definitely plausible and possible, illustrating how challenging this can be. Gonna skip over a couple more here in terms of, now, what we're gonna do now for a few minutes is play out how this plays out if you're in industry, okay? So this is the outbreak, this is what you see. So if you go into industry, and again, this is talking to undergrads, so what can happen? So you're in industry, you're the food safety person, and at some point in this outbreak, there was probably a call from CDC saying, hey, company X, you have an outbreak, currently 40 cases of E. coli 0157. We asked them some questions about food consumption. Majority of people say they ate spinach, and 10 out of these, or 9 out of these 40 people mentioned your brand. So we thought we just wanted to let you know, outbreaks occurred in August. So anything happening there? Do you have any evidence? Can you give us some of your data? Can you tell us which of your product you were distributing to certain states where these cases occurred? So that's what sort of typical call that might occur. So if you're the food safety person, you get that call. What are you going to do at this point? Alex, what are you going to do if this is you and you 10 weeks into your first job, you get in that call, you have to deal with it?
So I would look back at past data that we had, first of all, see if we have any testing. For EHEC, it's a little probably more sparse than you would like in this case. I would also look at different distribution chains, as we talked about a little bit.
So you would just hop off the call with CDC saying, let me do some searching here, or would you ask them some questions?
Oh, I would probably ask them some questions first.
So what questions would you ask?
Were there any other brands that were implicated? Any other potential foods that were possibly implicated? Basically, I'd want to find out if there's any way that it could be anybody besides me.
Right. Yeah, so or maybe different products. It makes it sound like you don't want to fess up to it if it's your problem. Yes. But first I would say, okay, so out of these 40 cases, how many indicated spinach? Where were those cases? Can you give us some idea where those cases were? Was this a complete case control study? Were there other foods that sort of had some associations with this outbreak? Other leafy greens, other produce, maybe some completely other products? What else were there? Did you have any other evidence? Among the patients that mentioned my brand, were there other brands mentioned? How many people mentioned other brands? Do you have any ideas on, do you have any of the products? Because you want to get an early idea. They may already have some bags that they're starting to test. You want to, so there's a bunch of questions I would ask very pointedly for you to also know, okay, what are the particular dates? I would ask a lot about onset dates too, because okay, what was the onset date of the disease cases? Can you give me a range there? Because then you can say, okay, disease cases happened, let's say from August 1 to 15. All right, so our product takes about 4 days until it gets to a consumer. Depending on the states, depending on the type of outlet, you might modify it and say, okay, I'm really got to look at my production records on sort of like July 22 to 25 or July 20 to 28. So you want to narrow down the time frame when you got to look at some of your products and your test results. You might not have EHEC positives, but you might have total plate counts higher. You might have some other issues that you might want to start tracing back which farms you sourced from at this time, all those sorts of things you might want to start doing. But yeah, definitely try to extract as much information from them as you can. And then go back to this. So this would be first one. Then, at some point later, you're probably going to get a call from CDC. It's us again. We tested an open bag of your brand and it tested positive. Or often they might not even say it's a bag. We had some product from one of the consumers, from one of the patients, and we tested it and tested positive for E. coli. And then, questionnaires like, well, was it an open bag, unopened bag? Can you give me the lot number, any of the codes, so I can trace this back, try to get that information.
Yeah, and also ask how many bags they had.
Right. Yes, how many bags they tested in general? Did they test bags from others? Right. And then, at some point later, it's me again. Now we have the E. coli from your product. It matches the human cases that are part of the outbreak, and so on. So as you go through these sequential calls from CDC or FDA or your state health department or your state ag and markets department, what else do you have to think through? What decision are you going to have to make at some point?
You have to start to think about, is it just the lot associated with that bag, or do I have to go out farther? What fields are potentially also implicated in this? Is it only one processing facility? Is it multiple processing facilities?
Are you going to shut down your facility at some point voluntarily? Are you going to issue a recall at one? When are you starting to think and have conversations about that?
I think once they matched, they found it in your product, and they have the subtyping data to match it back would be pretty good evidence. And there isn't, well, yeah, at that point, you definitely at least have to recall.
Well, if they find it in your product, it's a closed
Yeah.
bag, right? Then you have to recall.
Yes.
That's the end of story right there. Then the question just becomes, do you just recall that lot, or do you recall how much other stuff do you recall? Do you recall everything produced that day, everything produced on that line, everything that has a link to the ranches that were tested? Then it gets pretty complicated pretty quickly in terms of decision making, right?
Yeah.
Open bag. So the big question is, okay, open bag of your brand. They mentioned your brand here. They have an outbreak. You have a code. At this point, do you recall? At this point, do you stop production?
It's just the one open bag and you don't have the matching subtyping data yet?
No, but a bunch of patients mentioned your brand.
Probably. It might not, you might not be the entire cause of the outbreak at that point, but I think there's fairly good evidence that it is in your product and you want to get that off the market as soon as possible.
Yeah, so with one, I agree with you. Even with one open bag, I will probably start to recall. 2 positives from 2 open bags, definitely.
Yeah.
I would typically not wait until you have a fingerprint match. Even with a fingerprint match, you can still argue about it's an open bag. You don't know where it came from. But with this evidence, and part of it then depends on how big a brand you are, right? If you're the biggest, baddest brand in the US and everyone eats your product all the time, very different than if you're sort of a medium, small brand where, you know, 8 out of 10, 40 patients mentioning my product when I only have a market share of 1%. Well, oof, that's a problem. And then it's versus, you know, 5 out of 40 patients mention my product and I have a market share of 60%. Different story, right? Altogether. Okay. So let's review quickly what we learned from this. So we learned about the steps in an outbreak investigation, how you start by finding cases, define clusters, then use questionnaire to identify potential sources, food testing, and then try to identify the source of the food. Yeah, we talked about routine surveillance and lab testing, DNA fingerprinting as sort of the standard method for identifying these outbreaks and for the triggers for these outbreak investigations. And we learned a little bit about sugar toxin producing E. coli or enterohemorrhagic E. coli at the same time. Yeah, severe disease, you know, cows as common carriers, but probably other sources too. Important sort of a detail there is there's 2 concepts. There's sugar toxin producing E. coli and enterohemorrhagic E. coli. Often these terms are used interchangeably, and if you work in industry, you will see this. Sugar toxin means the E. coli makes the sugar toxin. Enterohemorrhagic E. coli, those that make the sugar toxin and also make molecules that allow them to really attach well to the human intestine. So they can cling onto your intestine, make the toxin, and pump it into your bloodstream, which causes that severe disease. So typically, the severe disease cases is enterohemorrhagic E. coli, even though a lot of people call him sugar toxin producing E. coli. The spinach outbreak, you know, was obviously a big one. It was one of the early ones, and it had a lot of consequences in terms of policy, et cetera, with regard to produce safety. Another little thing you see here is like at some point, those of you who sort of paid attention going to be like, well, what happens here? It was 199 cases. Now it's 205 cases. You know, what is it? Again, not unusual in these outbreaks because you get data from 26 states. You know, it's not quite like elections where there's a lot of ballots lost, but, you know, outbreaks get lost, isolates get lost, cases get lost. And so counting and getting the same number doesn't always occur, but it's the same outbreak despite the fact that the numbers sound slightly different. We're going to finish up with a quick case study on Cyclospora. And it started out, this is a 2020, so current, more recent outbreak, multiple people positive for Cyclospora. Again, same story. Here we don't have subtyping data, but Cyclospora isn't that common a disease. So if you have multiple people with Cyclospora, we do interviews. In this case, we identified specific grocery stores, specific private label bagged salads. A little bit about Cyclospora to help us interpret this outbreak. It's a parasite, typically spread by food and water, 7 to 10 incubation period. Symptoms for 2 to 4 weeks. And classically, Cyclospora outbreaks have been linked with imported product. There was raspberries, cilantro is a common one, basil, but also lettuce. So this is sort of our classic. What did this outbreak look? So at the beginning, we had cases like 6 states in the Midwest. It got bigger, more cases in the Midwest. Even more, started to add some on the East Coast here. And more, and the case numbers increased. So this is what we have. Cyclospora being a parasite, which is similar to some viruses, not that easy to test in foods, right? Plus longer incubation period. E. coli has a short incubation period. People are gonna have open bags. Cyclospora incubation period is longer. The disease symptoms are not quite as severe initially. So you're not gonna find a lot of open bags that are linked to this product. Plus Cyclospora is difficult to detect. So much, much harder to find product positive. So this is where often you have to take action, and the company is sort of pushed into potential action based without any lab data. This is something that's very, very challenging for many companies. So ultimately, this one was sort of linked to a facility that made bag lettuce in Illinois. So it's sort of this classical, most of the cases are close to where the facility is. Compare and contrast. So this is one area here, and we actually picked up North Dakota, South Dakota cases versus this very distinct pattern for the E. coli outbreak. So you can see, the patterns of spatial distribution can help you identify, hypotheses what might have happened. And so this is sort of what we had when the end of the outbreak was announced, multi-state outbreak, more than 1,000 confirmed cases, long May through August, onset date, 35 states. And it was linked to products made by Fresh Express containing iceberg lettuce, red cabbage, and carrots, sold in separate regions through many different outlets. And it was in a facility in Streamwood, Illinois. So where do you think it came from, Mr. Swan? How do you think? Yeah, let's start off with this. What happened here? I mean, so if you're with Fresh Express, you're hired, saying, okay, Samantha, you hired with us. You got to make sure this doesn't happen again. What happened? Where did this come from? What do you think? What would you do? Where would you look?
So I would first look at the distribution before our facility, because
So typically, I wouldn't call it a distribution. I look at my supply chain. I look at my raw material sources, right?
Right.
Distribution, often people refer to when it goes out. So what comes in will be sort of okay.
So we would.
You gotta look.
Yeah, go.
And what you're looking for, Mexico?
Based on historical associations, I would look at Mexico, because Cyclospora is known to be transferred through feces into water. It's a human parasite, so water that is contaminated with Cyclospora from feces in Mexico would probably be where I would look.
So why So we can dig it. Food safety is pretty easy, right? I mean, all you need to know is some basics. E. coli is cow. You have an E. coli outbreak, I find you the cow. You have Cyclospora. Cyclospora is Mexico. I find you Mexico, right? No, that's not how simple it is, right? It's a lot more challenging. And I'm sorry, I'm kidding. but it will happen that some people do, and I think that's one of the challenges we have. So where else would you look? So you look at your supply chain, but why wouldn't it be Arizona or Florida, or maybe a field where they grew carrots in New York? Why not?
Well, it could be in a water source in Arizona or California or the Mississippi River, right? Because the processing facility that carried out the recall was in Illinois, so close to the Midwest, or like the center of the U.S. So we could also just look at other water sources throughout the continental U.S. as well, because I think that the overarching principle is that Cyclospora does not grow without human, it doesn't grow outside of the human body. So it's different from bacteria, which will multiply in a nutrient-rich niche, like on a meat, you know, like, right, like basically Cyclospora will not usually grow on a produce commodity, so we wouldn't really look at the carrots, we would look at water, but we should be looking at water everywhere, I guess.
Right. Well, so the first thing I would look at is like, so the good news, if there is any, is that it's a long range. So when we really look at, hey, if it's that long a range, which product here is sourced from the same area from May through August? Or, you know, that's illness onset, we have a long incubation. So it's like from April through August, mid-April through early August, right? Among these three things, iceberg, red cabbage, and carrots, it's the one that always comes from the same region. So let's say, for argument's sake, iceberg lettuce, the first 2 months comes from Mexico, then it comes from California for 2 months, then it comes from New York for 2 months. Well, probably not the iceberg then, right? If it comes in with the raw material. On the other hand, if my carrots consistently over that whole period, I always get carrots from this area in Florida, different story. That would rise high on my list. So that long stretch of this outbreak gives you some evidence of where to look in your supply chain. If something moves around, probably not so much. And again, this is important for our listeners. I'm making this shit up, right? I mean, I don't know what happened there, but this is how I would look at it from a root cause analysis. Another thing is I would not exclude a source in the facility. Yeah, I know classically it's, you know, fecally contaminated water or fecal contamination in the fields because of lack of proper toilet facilities, etc. But, you know, I can't exclude that it's a worker, multiple workers, even water in my facility. So I would put that much lower on the list, but I would still look at that as a potential source. You know, field workers, you know, it doesn't have to, anywhere could bring it in. You know, they could be contaminated, they could be infected with it. But I think one key thing we have here is we need to look at one of these ingredients, one of those components of my product that is more or less consistently sourced. It's very unlikely that, you know, I'm bringing in, if it's a product that comes in from New York and from California, that's contaminated at both sites. So that's one way to look at it in this case. So distribution of the cases plus the length of it really can help you to sort of think through in the supply chain where things might come from. So this was the last one. So I hope everyone that this sort of maybe slightly different approach to look at things taught you a little bit about how to think through these outbreaks, what you might be challenged with if you ever get put into a situation where you have to deal with an outbreak, or have to maybe not deal with an outbreak directly, but sort of have to work through preventing future outbreaks, etc. And in our next series, we're gonna sort of cover 2 more produce outbreaks to learn some more. Thank you very much, and that's what we had for today.